Let's start our class. So we have been discussing about Java features for the last 2 days, and so far we have covered the topics that has been highlighted in yellow. We have covered this topic. Next day we have just started about the robust. I mean the future. Why Java is called the robust programming language. This topic has been just started actually, isn't it? So let us continue this further. So we will understand what does the robust actually means, and why it is important to for any programming language to be robust, right? We will understand these things. Firstly, robust. When you say a programming language is a robust programming language, it means that the language is healthy. Firstly, the language is healthy, and the language is secondly we can say that the language is strong. Right? These are the internal meanings. These are the actually dictionary meanings. When you find the meaning for the word robust, you get it is healthy or it is strong. Java programming language is a strong programming language. So from our understanding, how do we define a programming language as a robust programming language? How anyone can conclude that Java is a robust programming language? We need that conclusion. We need that understanding, isn't it? So we'll understand that. So Java is robust programming language because of the four things, right? Because of the four things, let me categorize one by one. Firstly, it is a strongly typed language. Strongly typed language. And secondly, we can say that it uses garbage collector mechanism to destroy useless objects. Mechanism to destroy unused objects, I can say. Instead of useless objects, I can say unused objects. Thirdly, it is robust because internally handles exceptions with the exception handling mechanism. And at last we can say it is robust because we can conclude that it is what platform independent. We can consider that as well. Since it is platform independent, as it is platform independent, it is it is considered as a robust programming language. Because again I am taking robust is nothing but a programming language is said to be robust when it is strong. Any programming language can be considered as a strong programming language when it can run on multiple devices or multiple platforms. Java has that credibility. What credibility? You can write program only once without even making any changes. You can use the Java program to run on multiple platforms. When something is strong, when something is when something is crossing against all the barriers, all the vulnerabilities, we can say it as a strong programming language. That's why I am including the platform independent here. The reason why Java is robust because it is platform independent. You can run the Java code on any number of platforms, right? I hope that is making sense. At least as it is a platform independent language, it is called as robust programming language. So we will understand one by one. Let me explain you about this. Why it is a strongly typed programming language. What does it mean to be a strongly typed programming language? We need that understanding. So let me take this as a separate category. Strongly typed programming language. I'm going to give you a small example. Let us say that I have three set of data, three set of values, I can say. Instead of data, let me take three set of values. So firstly, I have a value like 10,000 in the form of a number. Secondly, I have another value which is in the form of alphabets. I can say Ganesh. This is my second value. And thirdly, I have a value like a floating point value. For example, let me take a value like 100.95. Right. So these are the values. However, I have a requirement to store these values using Java programming language. By using Java programming language, my intention is to store. I have to store these values. Right? I cannot directly store these values before even actually storing this proceeding to store the values. I need to create an identity. Right. So this is 10,000. I need to create some identity for the 10,000. What is this 10,000 actually? I can simply keep the identity like 10,000 is the fees for a particular training. I can say this is the identity. Ganesh, what is the identity for Ganesh? We know Ganesh is a value here. You want to keep an identity for this. I can keep my own user defined identity, which can be, in this case, I can say student name. Student name can act as an identity to store this value. Right. Thirdly, this is something 100.95. I can say that this is some kind of identity where I am just keeping the identity as say that recharge, mobile recharge, something like that. So whenever you want to save some data in the Java programming language, we will have to ensure that it has an identity first. Firstly, we should ensure that the particular value is getting an identity. Identity in the sense any user defined name, right? So these are the values and these are the identities. It can be user defined. It will not stop till there. Again, we have to give another thing, which is the type. So what kind of data is this? Java has to understand what kind of data that we are going to save. We have to declare the type, right? So it cannot save any values without declaring the type. So Java programming language has to understand that what kind of data you are going to store in the memory. And here you are going to say, as a developer, you are going to say, hey, I am going to store the fees, value of my fees, which is going to be a type integer type. Then Java will understand, okay, the developer is going to store a value, store a data that represents, that is declared as integer type. And this is secondly, this is something, an alphabetical, we can say that an English word. We know that this is a name. We know, as per our understanding, we know that it is a student name. When the same things needs to be stored in the data by using Java needs to understand this. What kind of data is this? Java can understand only primitive data types. Right? In this case, this data type can be understood by Java only if we declare the data type. The data type in Java is nothing but string, because names can be represented in the form of string. And Java can understand, okay, the developer is trying to save a sequence of characters. Java will be understanding this. Right? Me as a developer, I can understand the mobile recharge. It's going to be 100.95 in the form of floating value. When you want to save this data, Java needs to understand what kind of data that you are going to store. So you are going to say it is a floating point. This is something that you will declare. This is the declaration. You declared with the data type float. Right? So what is happening here? Java is considered strongly typed programming language just because it is going to demand the every variable with the data type. It will ask you to store the data type by declaring it to a specific data type. You store the variables or store the values by specifying it to a data type. That's why it is called a strongly typed. By seeing this, right, For integers, you will have to save the data with the integer data type. For a string, you will have to save it with a string data type. For a floating point value, you will have to change with the float data type. This is called as this is why it is called as typed programming language. This data now you can use Java programming language, right? And by using Java programming language, this data can be stored, or this data can be used in your program. This is how. So Java. Okay, these things are added in your Java code, right? After this, what you will do, anyhow, every time we need to perform the compilation. Compiler, what compiler does, right? Compiler will check if there are any errors in your code or not, right? The purpose of the compiler is to check if there are any errors in your code or not. As simple as that. That's the compiler duty. Compiler is bound to check if there are any errors exist in your code or not, right? The code has no errors, then it will be the code is ready for the execution. The code is ready for the execution. And if the code has any errors, the compiler will not send the code for the execution. Instead, it will ask you to perform the correction. Do the corrections. It is going to throw an error stating that there are some errors in your code. Please do that correction. Without any corrections, I am not going to send it for the execution. Right? So because of this operation, because of this complete operation, the chances of failing the Java programming language during the runtime is very less. Is the takeaway. Because of this operation, what I'm writing it in the red letter, the chances of making the Java program to fail in the runtime or in the execution time is very less. You cannot fail the Java program in the runtime because all the corrections, all the errors that is getting accumulated in your code will be corrected by the compiler itself. Before even running the code, compiler is taking care of that. If there are any errors, it is not going to send the code for the execution. It will ask the developer to correct those errors. And after correcting those errors, if the code is error free, then the code will be sent for the execution. The pre-checking is done by the compiler. Compiler is taking care of the pre-checking. Right? Because of this, the Java is becoming very strong. In the sense, in the runtime, it is becoming very strong. There are no flaws, there are no errors. If any program has no errors or no flaws, there are less chances for the program to get disrupted in the runtime or to get failed in the runtime. Then that programming language or then that code is called as the robust code. Right? So this is what the strongly typed programming means. What does it exactly means? It will check the data that you are sending, the data that you are using, the data that you are sending or using in your Java code is properly typed or not. Typed in the sense properly declared or not. It's a proper declaration. Proper declaration. If it is an integer, declare that in the integer data type. If it is a word, use the string data type. If it's a float, use the float data type. Right? So Java code, if it is properly declared and compilation is successful, then the code will be ready for the execution and there will be less chances for the code to get failed in the runtime. Application, you cannot bring down this application or you cannot bring down the code during the runtime. Right? So in other words, I can simply say that the chances of making the Java program to fail in the runtime or in the execution time is very less, just because the compiler is taking care of all the errors. All the errors are, cautioned by the compiler. Compiler is like, hey, if you just send me the error-free code, I will be sending that error-free code for the execution. Until and unless you find any errors, the code will not be sent for the execution. Right? So this is what strongly typed programming language does. That is why it is called as robust programming language. I hope you're able to understand this. So secondly, we have I have also categorized one more thing, which is it uses garbage collector mechanism to destroy unused What unused? I forget here, right? He mentioned unused objects. So before even proceeding with this, let me like give you a small like example why there are less chances for the Java programming language to fail in the runtime. I'm going to give you a real-time example. My example is like, so have you heard about cyber attacks? There are so many cyber attacks that is happening in the real world every day, every single day. The internet world is facing a lot of cyber attacks. The cyber attacks are very common in India and in the world nowadays. Right? So in the cyber attack, some attacks are categorized like DDoS attacks, DDoS or DOS attacks. Right? So this understanding is required. I am giving you some real-time example. Please focus here. So DDoS, what do you mean by DDoS? DDoS is an acronym which stands for, let me write it here. So it stands for Distributed Denial of Service Attack. Denial of Service Attack is one of the common attacks that any website or any server uh, witnesses every single day, even in India, even in the world. And again, DOS, it stands for Denial of Service Attack. So both are almost same. There is a marginal difference. We are going to see that. Denial of service attack. So this is one of the cyber attacks, and these attacks are often performed on a particular website or particular servers. And we will understand what this attacks exactly does to a particular website. Right? So let us understand. Let us take a small understanding. Let us understand this with a small request and response. So let us say that I am a client. I am the client. Or let us say that Ganesh, you are the client, and this is what your system. You are working on a website. I mean, you are trying to get your. Assume that you are trying to get your semester results. Your semester results are announced, right? It is kept in a server. So let us assume that this is a server, right? And it is announced. It is just announced, and you are trying to check your results by entering into your university website, right? Usually what you will do as soon as you try to get access to the website, isn't it? So you try to get access to the website. Getting access to the website is nothing but sending a request. So if you try to get access to the website, it is nothing but you are going to send a request. You are going to open the website. So this is a request that you are sending. You will enter. Usually you will enter your roll number. You will enter your university and so things, and the request will be sent in the form of in the website by entering your roll number, and the server is going to send a response, isn't it? Response is what the result will be displayed in your console. That is a response. Request is accessing the website and entering your registration number and the things that is required to get your result, and the response is the results that will be shown in your website. So this is a server. This is a typical request and response flow. Typical request and response flow. This is a request and this is the response. Right? So it is very it is very common that whenever the request is sent, a response will be given and you will be able to see the result, right? But you are not the only one person who is going to see the result, isn't it? So in the particular university, there are about more than 1 lakh students who have given the exams, university exams, and everyone will be awaiting to see the results, and everyone will be placing the request, isn't it? This is your request. Likewise, there will be many persons who will be placing the request. Because the world is very big and the university is very big, under one university, so many students will be affiliated or will be enrolled for a particular program or particular degree, and everyone will be looking for the result. Everyone will be sending the response to the same server. Everyone will be sending the response to the same server, isn't it? Everyone are placing the request to the server. Let us say that if this particular server is capable enough to, if the particular server is designed to handle 1000 requests at a time. It is designed to handle 1000 requests at a time. Okay? So there will be no problem. You can 1000 persons can send the request, 1000 requests at the same time. There will be no problem, because server, that is how the server is designed. Let us say that at any point of time the server is receiving 10,000 requests or something, not 10,000. Let us say 2,000 requests. So the handling capacity is 1000 requests, but it is receiving double the amount of the capable request, which is 2000 requests at a time. What happens? The response will be slowed. I mean, the person who are checking the result, they will receive the slow response. If you consider the time, it keeps on revolving, right? It keeps on processing. What if the requests are 3000 requests? Right? The server will be down. What if it is like 4000 requests at a time? The server will be crashed. Right? The server will be crashed. This is what happens every time when you look at the result, because at a time the huge amount of requests will be flooded in the server. That is something that we cannot avoid, that isn't it? Because the server is designed in such a way that it can handle so and so requests at any point of time. Right? So this is something legitimate. Legitimate in the sense accepted. These are the legitimate requests. What if, like, if you as a developer, let us say that the government, the specific government has designed an application, designed a website where you can file complaints. So this is a website where you can file some complaints, where public can file some complaints. The government website. For just for the understanding purpose, I am taking this example. A simple government, a typical government website, where this website is handling complaints. It is taking some complaints from the public so that the actions will be taken. Right? Government website, it is taking some, it is designed to take complaints from the public or from the citizens. They can like place the grievances, and the government website will take up their complaints, and they will take some actions. At the same time, this government website is also allowing to take up the emergency cases. What if you are in the middle of an emergency, and if you want to get some help, and you are trying to place a request with the government website, emergency request, right? The government will receive your request and they will respond to your emergency. They will attend your emergency, right? What if an hacker, what if an hacker or any other countries, trying to bring this website down? What he will do? He will deliberately send many number of requests at a time. At any given point of time, he will be sending n number of requests to this website, to this particular website. It's called a cyber attack. So the hacker is trying to send n number of requests to this particular government website. So because of this, as a consequence, a legitimate request from the citizens will not get addressed because the website will be down. In some moment of time, the website will be down. The people who are under actual emergency, they will not be able to place any request to the government website. Right? In other words, I can say that the infrastructure, they will create an infrastructure with multiple requests so that it is not able to handle the request anymore. The website will be going down completely. Right? So this kind of attack is called what? This kind of attack is called what? Denial of service attack. I can say distributed denial of service attack. Services will be denied. There will be no use for having this. This website will not work anymore because it is under attack at a time. So many requests has come in, and the website itself got crashed. So the common persons who are indeed in emergency, they will not be able to place any request. Right? These are the common cyber attacks. Right? So in order to avoid these attacks, what usually the developers design, they will consider some things like CAPTCHA thing. You might have seen this. What is this? A CAPTCHA means if you want to get access to the website, you have to prove that you are a robot. You are not a robot. Right? So in this way, you cannot develop any program, right, that is sending multiple requests. So this may be, if there is an hacker, he is not going to send this multiple requests. He will design a program. And this program is going to send this multiple requests at a time, at any given point of time. Program will actually send 1 lakh requests at a time. You can design a program like that, right? That's why in order to avoid this kind of things, we have a concept of CAPTCHA. What CAPTCHA does, it will check whether the request is coming from the human or from a computer. Right? In this way, you can make sure that the load is getting balanced properly. All the requests will get filtered properly. Requests will be filtered properly, isn't it? And at the same time, they have also introduced the concepts like the load will be balanced based upon the locations. For example, if you want to check Tamil Nadu government results, Tamil Nadu engineering exam results, only request that is sent from Tamil Nadu will be addressed. The request from Andhra Pradesh or the request that is getting sent from Karnataka, they will not give access for those locations. The access will be limited. That is another way of dealing with this distributed denial of service attacks. Right? And you can ask me, what is denial of service? What is the difference between denial of service and distributed denial of service? You ask me. Both are same. In denial of service, it happens with one system with the server. With the distributed denial of service, it happens with multiple systems with one server. That's the only difference. Right? Okay, sir. Everything is fine. What relation is between this DDoS and the robustness? Right? So Java internally has some APIs. Let me write it here. Some APIs which can be used to deal with DOS attacks. Because it is robust. Java is a robust programming language. Right? So far we have covered it is a strongly typed language, and on top of it I have also given you a real-time example like a denial of service attack. When you want to bring any website down, it is very easy, and so this will be coming under ethical hacking as well, and this is not accepted, but for our understanding, I'm just giving the explanation what does it mean like a denial of service attack, distributed denial of service attack. So when you want to bring any website down, you can send number of requests, and the server is not going to handle the huge amount of requests because it is designed for a specific amount. You can bring the server down. So because of this, forget about the government website or any examination websites, university websites. If a person is running a business based upon a website, the arch rivals or the rival gangs can attack that website, making sure that the person business is getting down completely, because you cannot access to any website when the website is slow, isn't it? This is what happening in the real world. These attacks are happening every day, and these very common attacks, and this can be avoided very easily with the programming languages, like by implementing some additional checkpoints like captcha checks, and by adding authorization, common authorization, and limiting access to the specific locations. So Java is good in dealing with these things. That's why it is also called as a robust programming language. Okay. Secondly, and I have already specified a point here, which is it uses garbage collector mechanism to destroy unused objects. We have seen this thing about garbage collection in the destructors topic. I will explain you once again about this topic. It's very interesting. So in Java, whenever you are creating an object, creating object is nothing but memory allocation. So you can allocate memory by creating any number of objects. For example, in this case, I am creating 5 objects, right? So 5 blocks of memory are allocated. This is one block of memory, and each and every block is representing some bytes of memory. Let us say that it is representing 2 bytes of memory. This is representing 2 bytes of memory. So this is representing 4 bytes of memory, representing 8 bytes of memory. This is representing 9 bytes of memory. This is representing 10 bytes of memory. So I have started running the program, and the program execution has been completed. So Java program has been created. So this is my Java program. Right? I have started the program, and the program execution has been completed. After completing the execution, all these memory blocks will be destroyed. Right? If I run the program for the second time, while running the program, the memory will be created. Right? After the execution, the memory will be destroyed. So when memory is getting allocated dynamically, when you require memory, you get memory. Right? After using your memory, after performing the modification, there is no point of saving the data, isn't it? The data can be erased because you have started, the execution is completed. There is no point of keeping the data in your RAM. Right? If you still want to keep your data in the RAM, what happens if you run the program for the first time? Let us say that for the first time it is occupying 10 bytes of memory. Run the program for the second time, it is going to occupy 20 bytes, because the previous memory base is being carried forward. For the third time, it will occupy 30 bytes of memory. And if you keep running for 100 times, right, it is going to occupy 1000 bytes of memory. Right, 1 lakh times, it is going to occupy 10 lakh bytes of memory. Right, soon the system is going to run out of the memory. That should not happen in Java. That should not happen with any programming language. When you use the program, when you run the program, consume memory. After the execution, deconsume the memory, deallocate the memory, destroy the memory. Right? When this is being made sure by the Java itself, this is being made sure, this memory allocation and the memory relocation is taken care by the Java itself. Especially the destruction, memory destruction is taken care by the Java itself. You as a developer, we as a developer, we do not have to worry about the memory deallocation. Java is taking care of that. With the concept of garbage collection. That is what it said. It uses garbage collection mechanism to destroy unused object. Right after the execution, all the objects will be destroyed. You can ask me, I have just mentioned unused object, right? We can also say that already used object also. Right? So this is one of the points where Java stands to be a robust programming language, because memory allocation and the deallocation, especially the memory deallocation is getting taken care by the Java itself. Right? So let me give you a small theory on this. Class 15A. So second point, what does it says? Java provides automatic memory collection or automatic garbage collection, which take care of the unused memory blocks or memory blocks will not be used anymore, and it will automatically destroys those memory. So automatically destroys those memory blocks after the just before completing the execution. And memory space will be cleaned, making way for the new execution. So this is one of the reasons why it is a robust. This is why it is also called as one of the reasons why it is called as robust programming language. Right? And thirdly, we have a concept of exception handling. If you ask me exception handling, it is very simple. Right? So far we have seen the errors. In the previous example, in my previous illustration, we have seen the example regarding the strongly typed programming language. What does it mean? Java will make sure that the data that we are trying to use as a declaration, as a data declaration, and these data declarations will be checked by the compiler. Likewise, if any errors that is happening at the runtime, any exceptions that is happening at the runtime, for example, this is my Java code. A Java code first needs to be compiled. So the job of the compiler is to make sure the code is error free. After compilation, what happens? It will be sent to the JVM. JVM is nothing but Java Virtual Machine. Right? So Java Virtual Machine will take responsibility to execute this code. It will convert this code into the machine language. The code will be converted to what? Machine language or native code. Native code is always in the form of what? Zeros and ones. And you will get so this code after the native code, this native code will be interpreted, and you will be seeing the output in the console. Sometimes the error may occur here. The error, there are high chances that some exceptions may occur here during the runtime. Sometimes the JVM will not be capable enough to handle those exceptions. If you ask me what kind of exception we get in the runtime, The commonly known exception is what? Arithmetic exception, which is like n divided by 0. If you include this in any statement, if you are trying to evaluate this, right, these things will not be checked during the compilation. This will be checked during the execution. Right? In the execution, it is going to, the program is not capable enough to handle this exception, so the program will be terminated abnormally. Abnormal termination will occur during the runtime. Right? So what Java says, right? Even though there are high chances that an abnormal termination occurs in the runtime, you can handle this abnormal termination with the concept of exceptional handling mechanism. This is some internal concept. What is that? This can be handled with the help of exceptional handling mechanism. Let me write that here. Exceptional handling mechanism. Right? With the help of exceptional handling mechanism, nothing but I'm keeping it very simple. This is a very big topic, exceptional handling mechanism. Let me keep it very simple. So in Java, there is a block called try block, and there is a block called catch block. Catch block. If you find any code that is potential enough to generate an exception in a runtime, right? No worries. When you are sure that a particular code is going to generate an exception in the runtime, please make sure that the code is contained in the try block. So the risky code, please handle that risky code, or please write that risky code in the try block. And Java will work on this exception. Java will handle this exception. In this case, 10 by 0 is going to generate an exception. Right? Include that exception in the type, include that code in the try block. Java will take care. Java will handle this exception. Right? So this concept is called as a concept of exception handling mechanism. So because of this exception handling mechanism, the risky code that is potential enough to generate an exception in the runtime, in the execution time, will be handled, and there are no chances for the program to get terminated abnormally. Why it will not terminate appropriately? Because internally we are using exception handling mechanism, which is a future topic. Because of this reason, Java is also called as what? Robust programming language. Right? These things are what we call it as this is a future topic, and for the time being, that the Java futures, just think that there are chances that exception will occur in the runtime that can be handled with the help of exception handling mechanism. Right? Because of this mechanism, Java is called as a robust programming language. So why these three boxes are like this? This is a Java code. Java code needs to be compiled, and the Java code compiled code has to be sent to the JVM. JVM will generate what? Native code or machine code. And while executing this native code, there are chances that the exception may occur. This is the code that is potential enough to generate an exception. So whenever an exception is generated, the program will be terminated abnormally, right? But Java is given an option to handle this abnormal termination with the help of exception handling mechanism. Because of this, just because of this, and because of this, we call it as Java is a robust programming language because it is potential enough to handle exceptions. Okay. So these are the things that comes under why Java is a robust programming language, and also again platform independency, because a Java code can be run on multiple machines. So in order to run on multiple machines, there is no hindrance for the Java, no obstacles for the Java. Write the Java code once, Java will not face any obstacles. Run it on any machine. No code changes, nothing, because Java is strong programming language. It is capable, it is designed in such a way that it is adapted in any machine. As simple as that. This is a very deep explanation, and this understanding is completely required, because if you search in any theory books, For robust programming language, the theory will be like more than 4 or 5 lines. That is not enough. Understanding is required. That's why I've taken a lot of time. So we have completed this robust. Hope this is making some sense. Robust. Right. So nextly, we have also completed this object oriented. We have also completed multi-threaded extended. Right. So remaining topics are very easy. So now let's understand what is distributed. Why we call as Java is a distributed programming language. Interesting topic. Names itself or names are very interesting, isn't it? Very simple. If Java application, if any application functionalities are distributed to multiple systems, it is called as distributed application. Small example. This is very simple. So let me take. I have 2 machines. This is my machine 1. This is my machine 2. Right. Likewise, previously I have explained about the DDoS attack, DOS attacks. Right. Forgot about the DOS attacks. If this machine, if for example, if I am getting multiple requests. For example, if I am getting in the real time for to check your university results, if I am getting 1,000 requests at a time. Requests are nothing but when you open a web page, it is a request. When you click on submit, it is a request. Right? What is the response? After clicking on something, what you are seeing in the console, that is the response, right? So at a time, 1,000 requests are sent. So this request will not be sent to the servers or the machines directly. So there will be load balancers. What this load balancer does, it will transfer the load accordingly. For example, if you want to check your results, it will be there will be a code written in the machine name to check the result. So this is your app. It's what we call it as your government app application. So this application, this particular machine is going to handle request, which is going to show you your examination status, which is pass or fail. Right? So this request will be transferred or routed here. It's a machine 1. Right? And some in this the machine 2, this is a machine 2. This machine accepts results like what? If you want to apply for the what we call it as the recorrection, re-evaluation, those requests will be sent to. Right? One application can perform many actions, right? You can see it. You can do many things in your university website. Checking results is one thing, and applying for re-evaluation is one thing, and also filing a complaints will be handled by another machine, another server. Right? So what's happening? One application is just same application. So part of the logic is distributed in one JVM, and the remaining part of the logic is distributed in another JVM. You are just splitting the code into several pieces, right? And each piece is handling a particular request. Right? So that you can do this by using Java program language. So in the Java program language, you can split the logic into several machines. Each logic or each machine is going to handle a specific request. Right? And that request, most of the requests will be sent it to machine 1, because machine 1 is going to check the results. Some requests will be for reevaluation, and some requests will be for what? To file any complaints. In some requests there will be many requests. All the requests are not going to be same from the end user, right? This application logic is distributed to all the machines according to the request. That is why it is distributed programming language is what? If any application functionalities, right, is distributed to multiple machines, it is called distributed. Java support distributed application. That's why Java is called as what? Distributed programming language. As simple as that, right? So what happens because of this? Do you think is there any chances of failover? Because of distributed applications, you are able to perform two operations here. First one is very important, load balancing. Load balancing. Secondly, you are performing what? You are not performing anything. There are less chances for the failover. Failover in the sense, so you cannot bring down the website because there is a load balancer placed, and this load balancer will get to know what kind of request has to be routed to the specific machines. This load balancer is going to cater. Because of this load balancer, what will happen internally? There are less chances of failover. Again, the topic is we are discussing on the robust topic, right? It is giving justification to the meaning robust, isn't it? Justification to the word robust. That's why Java is called as robust programming language. Satisfies that as well. Right? So when someone is asking you what is why Java is distributed, Java is distributed programming language because Java application functionalities can be distributed to multiple systems. When any functionalities are distributed to multiple systems, they are called as distributed application. What is the advantage of distributed application? You can do load balancing. You can make sure that it is not getting failed over. Right? I hope this is making some sense now. So we have what? We have compiled and we have interpreted, and we have high performance. So let us understand this. It is also very easy. Compiled and interpreted. So what is compiled and interpreted? Let me make some space here. Very simple. Compiled is nothing but you are going to write a Java code. Right? Every time the Java code has to get compiled. The compilation will take care of syntactical errors. After compilation, the compiled code needs to send to the JVM. The JVM will perform the job of interpretation. Interpretation means the code will be converted, the .class file will be converted to the machine code, and the machine code will be will be sent for the execution. Right? .class file will be converted to the machine code, zeros and ones, and the zeros and ones will be interpreted and translated to give the proper output. That concept is called as interpretation. After JVM, you are going to get an output. Okay? This is the concept of compiled and interpreted. Compiled in the sense, let us say that this is my test.java. Right? Test.java becomes what? After compilation, it becomes test.class file. And this test.class file will be sent to the JVM. JVM will going to generate a byte machine code. This machine code will be executed to give the specific result, specific output. So this is called as interpretation. Compilation is happening here. Interpretation is happening. Interpretation is the actual translation. The machine code is getting converted again to the specific output, which is nothing but the human understandable thing that can be displayed in the console. Interpretation is happening here. Right? Every time between the compilation, because of the compilation and the interpretation, the output is going to be smooth always. So there are less chances, right? There are less chances for the Java program to to fail. In this case, the output is going to be smooth. Why the output is going to blue? Because Java is a compiled and the interpreted programming language. Because all the errors are eliminated in the compilation, right? And the JVM will make sure to convert the dot class file to the machine code. This machine code again will be what internally translation will be performed in the machine code and the code will be executed. Right? That's why it is called as compiled and interpreted programming language. If you see Python and all, in the Python there is no concept of compilation. Directly it is interpreted. So there are high chances that some of the errors will not get addressed during the, because there is no compiler. So all the errors needs to be get addressed in the runtime itself, isn't it? So there are high chances that the program may face a lot of exceptions. But in Java it is not like that. Most of the errors are getting eliminated in the compilation itself. This is an advantage. You have to take this as an advantage because it is the future of Java. Now the futures. Is it compiled and interpreted? Right? So I think this is also making some sense. And we have remaining two things: dynamic, why it is a dynamic programming language and why it is high performance. It's a matter of 20 minutes. We'll continue this tomorrow. But we have completed almost all the features, all the buzzwords.